Hey everyone, today we're going to start talking about the last topic in this AP chapter, and we're going to be talking about average value. So if you think back, this has actually come up in a few of the AP questions that we've done before, but we've skipped it because we hadn't quite learned this piece. So today we'll cover this, and we'll be kind of circling back to some of those questions that we had skipped earlier. So just as a quick review, if we wanted to find the average of the following test scores, hopefully we all know what that would look like. We would just add up the test scores. So 65 plus 70 plus 75 plus 80 plus 75 plus 83 plus 68. So we would add up all the scores and then divide by how many scores there are. So 1, 2, 3, 4, 5, 6, 7 scores. Okay, so then we'll just use our calculator to do that, right? Obviously, this is a very straightforward problem. Nothing new. 83 plus 68. And I'm going to divide by 7. And so I get 73.714. Okay, would be the average of the test scores. So it's really easy when we have a finite number of things that we want to count up and find the average of. Now, it's going to be a little bit different. What we're talking about today is finding the average value of a function. So, it says finding the average of a set list of numbers is easy. We just add and then divide by how many there are, like we just did. Okay, but when we want to find the average y value of a function, that's harder because we have an infinite number of y values. If I look along this curve, there's no way we could find each one of those y values to be able to add them up. So this is how we're going to do it. In order to find the average value of a function on an interval from a to b, here's what we're going to do. We're going to take the integral from a to b of f of x dx, and then we're going to multiply that by 1 over b minus a. That's going to give us the average value of that function. So sometimes you'll see me denote it by f with subscript average. So the average value of that function is 1 over b minus a times the integral from a to b of f of x dx. So you'll see this in problems. Either they'll be asking us to find the average function value, or they may be asking us to find the average value of something. So for example, if I have a temperature function, they'll be asking you to find the average value of the temperature function. So asking you to find that average temperature. If we have a cost function, they might be asking for average cost. So if they're asking you for the average of something and you have a formula for that thing, we'll be using this average value definition. So let's take a look at what this is going to look like in some problems. So it says, one day a strange weather system moved into town, and the temperature in degrees Fahrenheit over the next 24 hours was given by this formula here. Okay, so T is in hours, and the time period was from 0 to 24 hours. Okay, so for number 1, it's asking us, what is the temperature at T equals 0? Well, if I just want to know the temperature at T equals 0, I'm just using my temperature function. So I have 70 plus 2 sine of 0 over 2 is 0, minus 0 over 2 is 0. Well, I know sine of 0 is going to be 0, so that initial temperature at time 0 is going to be 70 degrees. Now, if I want to find the temperature at time 24 hours, we're going to have to do a little more work here. So 70 plus 2 times the sine of 24 divided by 2 is 12. Minus t over 2 is 12. We'll use our calculator here. So 70 plus 2 times the sine of 12 minus 12. And I get approximately 56.927 degrees. Okay, so now if I want to average those two values, all I'm going to do is add them and divide by 2. So here I'm going to do this in one step. I'll use parentheses 70 plus 56.927 and divide by 2. And I'm going to get 63.464 degrees. Okay, so that was easy. Again, that's a finite set of things. I have two temperatures. I want to find the average, so I add and divide by 2. Now, this is asking what is the average temperature using an integral. Again, I'm trying to find the average temperature. My function is a temperature function, so we're just going to find the average value. So, average temperature, my interval is from 0 to 24. Again, that's my A and B. So I have 1 over 24 minus 0 times the integral from 0 to 24 of my temperature function. And again, I'm just going to use my calculator here. So now I'm going to put that 1/24, 1 divided by 24 in parentheses. I'm going to use math 9 to do the integral from 0 to 24 of, and then I'm going to type in my temperature function. 70 plus 2 times the sine of x divided by 2 minus x divided by 2 dx. Okay, and so then over that 24 hours, I know my average temperature was 64.026 degrees. Okay. So on the next page, this is asking us to find the average value of the function over the given interval, and then we'll use our calculator to check. So again, average value, here's my interval from A to B. So I'm going to do 1 over B minus A times the integral from A to B of my function, 1 plus x squared dx. Okay, so I can simplify 2 minus a negative 1 is 3. So I have 1/3. Now I'm going to anti-differentiate it. So I have x plus x cubed over 3. And I'm evaluating from negative 1 to 2. So I'm going to leave my 1/3 out front. I'm going to get 2 plus 8/3. And I'm going to subtract negative 1, and this is going to be minus 1/3. So I have some simplifying to do here. So I have 1/3, let's see, 2 plus 8/3 is going to be 14/3, minus, this is going to be a negative 4/3. So now I get 1/3, 14/3 plus 4/3 is 18/3 or 6, and so we get an average value of 2. Again, that was largely just some simplification in these steps. So we'll go ahead and use our calculator to check. So I have 1 divided by 3 times math 9 to get my integral. Let me see if I can move this where you can actually see the screen. There we go. From negative 1 to 2 of 1 plus x squared dx, and we get an average value of 2, so it checks out. Okay, so now we're going to learn a new theorem, and it should sound pretty familiar to one we've learned before. This is going to be the mean value theorem for integrals. And if you remember back, we also have a mean value theorem for derivatives. But this one says, the mean value theorem for integrals says that if f is continuous on a closed interval from a to b, then there is some point c in that interval such that f of c is equal to 1 over b minus a times the integral from a to b of f of x dx. Well, hopefully right away we recognize that this piece is just the average value of f on our interval from a to b. So really all that this is saying is that the function takes on its average value at some point in that interval. So if it's continuous on that closed interval, it's going to take on its average value at some point C in that interval. If you think back when we talked about mean value theorem for derivatives, all that said was that at some point in the interval, the average rate of change was going to be equal to the instantaneous rate of change. Okay, so now we're going to do a couple problems using the MVT for integrals. Okay, so it says using the mean value theorem for integrals and the same function as problem number 4, which I guess is really number 3. Okay, find a point C on the interval that satisfies the MVT for integrals. So if we're going to use it, first we need to check. My function is 1 plus x squared. Since that's a polynomial function, I know it's going to be continuous everywhere. So we know that MVT applies. We always want to check that first. So now we want to find the point C where f of c is equal to the average value of the function. So we want to find where does that function value equal its average value. So f of c is just going to be 1 plus c squared. I'm taking my function and substituting c for x. We already found the average value, right? So in this case, it was from 2 to negative 1. So it's the interval negative 1 to 2 of f of x dx. We already found that average value was 2. So now we just have to solve our equation. 1 plus c squared is equal to 2. So I'm going to subtract 1. C squared is equal to 1. And so if I take the square root, I get c is equal to positive or negative 1. Now the only thing I want to do is check that both of those solutions are in the interval. Since our interval was from negative 1 to 2, both of those solutions would apply. So all this is saying is that positive or negative 1, the actual value of the function is equal to its average value. We knew its average value was 2. Well, I can check really quick. If I plug in a negative 1, I'm going to get a function value of 2, which is equal to the average value. If I plug in 1 to my function, I also get 2. So we can check that that is correct. All right. Sorry about these numbers. We're going to jump to problem number 1 here. Okay, so same idea here. So we're going to find the average value for the following functions, and then we want to find the value of c that satisfies the MVT for integrals. So let's do the average value first. So here's my function and my interval from a to b. So my average value is going to be 1 over 3 minus 2 times the integral from 2 to 3 of x cubed plus 1 dx. So this is easy. This just simplifies to 1 over 1, or 1. My antiderivative is x to the 4th over 4 plus x. I'm evaluating from 2 to 3. So now let's see. 3 to the 4th is going to be 81. So I have 81 over 4 plus 3. And we're going to subtract. 2 to the 4th is 16. Divided by 4 is 4 plus 2. So let's see. If I simplify this, I can get 93 over 4, if I did that right. 12 plus 81 is 93. Minus, this is going to be 6, so it's minus 24 over 4. And then if we simplify that, we get an average value of 69 over 4. So that's the average value of our function. So now we want to know, where is our function? So I'm going to do c cubed plus 1. Where is that equal to our average value of 69 over 4? So if I subtract 1 from both sides, that's the same as subtracting 4/4. So I get c cubed equals 65 over 4. So c is the cube root of 65 over 4. And that's our answer. Okay, last piece here. Now we're going to do the same thing we've been doing, except instead of them giving us a function, we've been given a table. So we have a function f that's continuous on the closed interval from 2 to 8. So they're telling us that we meet the conditions of the MVT for integrals. Okay, it has values given in the table. We're going to use LRAM to approximate the average value for the function. Okay, and we're going to use the interval from 2 to 8. So again, I know the average value is going to be 1 over 8 minus 2 times the integral from 2 to 8 of, let's see, this was f of x dx. So now we're going to use LRAM to estimate the value of that integral. So we're going to do our left-hand approximation just like always. Let's see, it doesn't specify, so we're going to use the intervals given in the table. So 2 to 5, 5 to 7, and 7 to 8. This was a left-hand approximation. So I have 10, 30, and 40. So 3 times 10 plus 2 times 30 plus 1 times 40. Give us 30 plus 60 plus 40, or 130. So now my average value is going to be 1 over 8 minus 2, which is 1 over 6. We approximated our integral with our left-hand approximation, so that value is 130. So our average value is 130 over 6, or if we simplify that, 65 over 3. So that's really the basics of average value. In the next video, we'll look at some AP problems and see how it shows up in some of the FRQs. But that's, as long as you've got a good handle here, this topic should be pretty straightforward.